Hello class, this is Dr. Fenton. In this video, I'd like to show you how to work exercise 13-14. In this exercise, we're going to compute the net present value for two different projects and then compare the two projects to decide which one to accept. So let's get started. We have projects X and Y here, and they have the company has $23,000 to invest. Each project cost $23,000. So this is what they're going to pay out today. So this is today's money, keep that in mind. Now project X will generate annual cash flows of $7,000, and it will do that for 6 years. So each year for 6 years, project X will generate $7,000 in cash flow. Now project Y does not have an annual cash inflow. Project Y generates a total of $43,000 in one lump sum at the end of 6 years. So you can see the difference between the two. Project X generates cash flow every year for 6 years and nothing at the end, no lump sum at the end. Where Project Y does not generate any cash flow each year for 6 years, but does generate a one lump sum amount of $43,000 at the end of 6 years. So let's take these numbers and compute the net present value. The company's discount rate is 16%, so we're going to need this. So let's plug the numbers in. So project X, $23,000 cost and $7,000. I have an Excel spreadsheet set up to help us work this. So project X is going to generate $7,000 each year. It's not going to generate anything at the end of year 6, so I'll just put a 0 down there just to place it there. The original cost of project X is $23,000. So to find the present value of the future cash flow, and the future cash flow is $7,000 each year for 6 years, we need to find the present value factor. Going back to the problem, we need the present value of an annuity table. So here it is. And we're working with 16% for a total of 6 years. So to find the present value of $7,000 per year for 6 years at a rate of 16%, we're going to use 3.685. So 16% column, the 6 period, the 6 year row. So 3.685. 3.685. Plug that in, and this is worth, in today's money, $25,795. The present value of an amount paid today, today's dollars, that's worth what it is today. The present value factor is a 1. So place that in there. So we just computed the net present value of project X. It generates $7,000 each year for 6 years. Present value factor 13% at 6 years. It generates a present value of $25,795. That's the total present value, because it does not generate a lump sum at the end of 6 years. That's why this is 0. When you compare this year's investment to the present value of the future cash flows, we subtract, and we have a positive net present value of $2,795. Let's do the same thing for project Y. Project Y, still $23,000 initial investment, no annual cash flow, but it generates $43,000 at the end of a 6-year period. One lump sum at the end of 6 years. So $43,000, we're going to drop in right here. I'm going to go ahead and put 0 here just to show you that 0. Original investment, still $23,000. Now we need to find the present value factor for one lump sum at the end of 6 years at 16%. Going back to the problem, we need the first table, B1. Here it is. Present value one lump sum dollar. That's what this means. 16%, 6 years, 0.410. 0.410. 0.410. Drop that in. And I'll go ahead and put the present value factor here for today's money, still $23,000. So the present value of $43,000 6 years in the future at 16% is worth only $17,630 today. So that's the net present value. When subtract 23,000 from the 17, 5,370 is the net present value, and is negative, of project Y. So 2795 on this one. Going back to the problem, you can see that's the answer down here. Requirement 2 is project Y. There's the negative 5370. That's what we have here. And now the third item, which project would you recommend the company accept? Well, what do you think? You have a project that generates a positive net present value of $2,795, and we know that that earns more than 16%. I'm not sure what the exact percent is, but we know it's more than 16% because it has a positive net present value. Compare that to the next project that generates a negative present value of over $5,000. So project Y does not generate a 16% return. It's something less than 16%. So clearly you would want to choose project X because it has a higher, in this case much higher, net present value than project Y. So the answer here, requirement 3, is project X. So that's the solution. So good luck in your studies.